Hello and welcome to Andy and Iain Talk Networking. I am Andy.
And I'm Ian.
Hey Iain, good to see you again. How's life?
Life is great, Andy. Life is really, really great. It is certainly never a dull day in my life at cPacket or whatever. It's all good. Always an exciting time.
Good, good. Right, so networking. I want to talk about something we kind of delved a little bit in the past in one of our other topics where we talked about kind of our packet brokers all built the same. So I think one of the things I'd like to dig into today is how we can make the packet broker better. And the way I think we can look about that is really, how can we do hardware acceleration within the packet broker to solve, some specific use cases. So let's first of all start off at a high level, and we talked about the architectures of packet brokers and kind of inbound and out of band and kind of taking certain types of packets out to be processed. But let's talk about hardware acceleration and why it matters and what we can kind of do with that functionality.
Wow. Well, you've certainly picked a nice, small, easy,
Yeah,
straightforward
we
topic,
got
Andy.
usual 10
Of
minutes. It's
course,
fine.
as usual. But I think the key thing, right, is obviously software makes things very flexible and allows you to kind of make pretty dynamic kind of changes. And I think that that's fine up to a certain point. However, when you try and push performance, or maybe not, performance is sometimes a kind of a positive word, but if you're trying to maybe overstress a system, any system, when you're doing software, I mean, we've all been on those websites, trying to buy something and hitting refresh and refresh because the software is running that little
Yeah.
bit behind because maybe it's overwhelmed. You want those concert tickets or something very, very very much in your personal life or whatever, things like that.
Mm-hmm.
And I think the point is that when it comes to networking, using hardware. I mean, if you remember way back, and I'm sure we are both old enough to remember this, when you would do routing in
Yep.
software, and then you would overload those systems that would have all kinds of issues. And then, whatever it was 30 years ago, or maybe a little bit less than that, people introduced L3 switches,
Yep.
which didn't do everything, but they at least took a lot of the core functions and put them into more hardware type processing rather than
Yep.
pure software. And you see that jump in performance, you see that jump in
Yeah, I mean,
flexibility.
you've
And
got
then when
that
it,
dedicated resource specifically to do a task instead of a more general purpose processor.
yeah, absolutely. So if you come to what we're kind of really talking about today in the context of maybe packet brokering, let's say, if you're able to use dedicated hardware, which is able to process every bit of every packet as they come through the
Yeah,
system
at line rate. Yeah.
at line rate, then you're not only able to keep up with the network that you're really kind of observing, but also you're able to apply a number of potentially complex steps
Mm-hmm.
to make sure that you get all of the value out of those packets.
Yeah.
I think that's really the key point is the fact that you have those resources available.
Yeah.
And yeah, that's
Yeah.
really
Yeah.
the key thing there. You're taking all of that value, the software, the configurability, and you're rolling that down into some kind of dedicated hardware resource.
Yeah, and I think when you look at it, kind of in that perspective, and again, there are different architectures, so different brokers have different
Yeah,
ways of doing things.
yeah,
So
yeah.
some will do hardware acceleration, but they will do it kind of off processor, so you filter some of the traffic through or just one port. So having that hardware acceleration on every port allows you to do a lot of functionality at line rate at all ports,
Yes.
and really, you can do things like time stamping, you can do burst detection, and then you can do DPI. And obviously, our next topic, next week, we're going to talk about DPI and kind of how we do that. But, really, one of the things I like about, kind of having that hardware acceleration is that you can also do a lot of counting and a lot of kind of analysis of traffic flows in the hardware. So, if you take a use case, just a simple one, simple denial of service. Okay, there are lots of different types of denial of service, but if you look at DDoS that uses sync hack attack, in that scenario, having that ability to see every single packet that comes through and look at the sync requests and the sync acts and look for imbalances. You can't do that unless you're looking at full line rate at every single packet and you're looking at into all the details. So for me, I think, the hardware acceleration is, you can have it, like I said, you can have a hardware accelerator, but if you're not doing it on every single port, you just miss so much information that can be used to really understand what's going on. And I talk about those counters, but having that ability, in an application to have that level of insight really makes a huge difference.
Yeah, I think you're hitting on a very valuable point, Andy. I mean, if you take back to your other example with the DDoS, the kind of volumetric SYN-ACK kind of DDoS attacks, the point is that you don't want to look at absolutely every. Sorry, when you're trying to do DDoS counters, I'm going to trip myself up over my tongue. The point is, if you can pull out just those messages,
Yep.
right, you can easily count them. Now, yeah, you're doing lots of other functions, etc. But the point is, you're actually trying to look for that SYN to SYN-ACK ratio.
Yep.
And if you're doing it in hardware, you can immediately see as
When it goes out
something
of balance. Yeah.
goes out of balance. It's not, oh well, 10 minutes later I'll send it off to some other tool.
Yep.
Do it in hardware, because that kind of DDoS attack is very, very easy to spot in hardware.
Yeah.
And
it doesn't normally happen in the network. You may get, the odd one or two where maybe you get a little bit of a packet loss, but it's not, it's not a massive change in that ratio. But when you see a DDoS attack happening, you see a ratio of like 5,000-10,000 to 1. So it's very, very pronounced when the problem is there. But if you're not counting that data, you just miss it. Yeah, you're literally saying, well, why is my network stop responding, or why are my servers all offline?
Yep. Or I mean, or the other example, Andy, is obviously if you set it up to do that counting, and then you can't do other things, or vice versa, if you're doing something because you've only got a limited amount of that hardware resource, then I'll look for this, or I'll look for that.
I've got a very expensive dedicated box that's just doing one thing.
Yeah, and the point is, therefore, you're going to have real issues in the field. Maybe not in that kind of lab environment or this kind of environment or that. But the point is, you put that in the field, you've got to make sure that you have enough headroom to be able to keep you and your users and ultimately your network safe. Once again, we're just speaking about that particular example, and as I say, we'll have to see what we're going to talk about next week. But the point is that it's really, really important to think and come up with a good plan for what you're really trying to tackle when it comes to doing this kind of analysis. Don't have to choose between DDoS protection or something else. That is not a good equation.
Yeah, or you end up with distributing small boxes around the network just to do individual tasks, which become a management nightmare. You end up missing traffic. You end up with different timing problems, and you kind of all the things that we've talked about. Kind of in a lot of different subjects and topic matter. It's just not efficient. It's it's really difficult to then get all that information up to your analytics tools and into your alerting dashboards and your third-party integrations, and that's another topic that we're going to talk about in the future. So it's really important, I think, that when you're looking at how hardware acceleration can help you, and that packet broker is the kind of the first line of defense to a certain extent in seeing everything that's coming into the network. And the more capabilities you can give it to be able to understand, to characterize, to get flow information, session connection information, it really is important to get kind of that first level. And realistically, you need hardware to do that. We said before, having software tools, they've got a place in the world, just like we talk about tapags and packet brokers in the past. And I encourage people to go and look at those videos where we talk about the different kind of deployments and architectures and technologies. But having that kind of first line of detection defense, having hardware acceleration on every port at full line rate is just so invaluable.
Absolutely correct, Andy. I think that's something that everyone listening to this should be at least considering or trying to understand more about how the vendors or the other folks that they're talking to, how they are tackling these kinds of questions, once again, you need to find the right solution for your infrastructure.
Yeah, absolutely. Okay, great conversation. Thanks, Iain. Appreciate it.
No
Just like
problem.
to remind everybody to please like and subscribe down below to get notification when we make new releases. We make these videos weekly, but it's good to get you notified, and also it helps us to kind of track the analytics and other aspects of YouTube metrics. So appreciate you doing that. Once again, like to thank everybody for watching. I have been Andy.
I've been Iain.
Thank you again, and see you soon.